We previously added records to our curly language using the record form with get to get a field from a record and set to functionally update a record, producing a new one with a different field value. So in a record we have symbols, a symbol for each field name, and an expression to provide the initial value for that expression. A get has an expression that should produce a record, and then it gets a named field from that record. Set has an expression that should produce a record. It has a name for the field and an expression for the new value in the updated record. If we want to put this in typed curly, then we need types for records, and we're going to write record types like this. For a record, we need to record the field names, and for each name, the type of the field. So we'll do that with a sequence in curly braces and with square brackets around the simple type combination. So, for example, if we have this record expression, when we run this, it produces a record with an x field and a y field. The x value is 7, the y field is 12. The type that goes with this expression is curly brace, square bracket, x colon num, and y has type num also. So this type says that it's a record with two fields, x and y. Each of them have a number of values. We can nest records as we could before, so here I've created that same point-like record and then made that the value of p in this enclosing record. So this larger record, that has type, a record type that has one field p, but the type for the value of that field is another record which has fields x and y. When we have a get form, then this will work, we know, because it's going to produce a record that has an x and y field, and then we're getting the y field. When we look at types, then the reason we know that this get on y will succeed is that this record sub-expression has type x is num and y is num. And so we know just from that that get will succeed. We could replace this record expression with some other expression. As long as that other expression has this type, then get will certainly be able to get a y at runtime, and furthermore, the value that it gets will be a number. If we nest records like this, then again, the get, we can check that it will work because this record here, as we saw, has this type, p, which has a record as its field value. And so we know that the get will succeed on p, and then the result of that will be a record where the get will succeed on x. And then looking at set, if we set on this record, again it could be some more complicated record expression, more complicated expression that produces a record, but from the type we know it will have an x and a y, and so the set on y will succeed. And so what we'll end up with is something with the same type, value at runtime, but at type checking time also this overall set form should have the same type as its argument record type, right? As long as the type of the new value of the field matches the expected type of the value of the field. And then we can mix this with let and lambda. So here I'm letting r be a record, and then when I do that I need to write a type down for r. So I've written the record type there, and using only this record type for r, we know that the get and the y will be okay. The get on x and y will be okay. Let is of course just a pattern for lambda, so we might have a lambda that takes a record as an argument. Here, this lambda, this function takes a record that has just an x field in it, and it gets the x field out of that. So that should work out okay. And the function itself has an arrow type, of course. Its argument type is a record type. So this function has the type, give me a record with an x field that's a number, and I'll give you a number back. If we do a functional update inside of the function, then it's taking this record that has an x field, and then it's updating that x field to have the number 1. The overall type here is give me a record that has a number, field x, and we'll give you back the same sort of record as a result. Here I'm taking that same function and binding it to f, and calling f on this record here. And we can see that this function call is okay because the type of this expression, this record expression, is a record with x of type num, and that's exactly what f wants as an argument. If we write down these rules more formally, then here is the typing rule for record. It says if you've got a record with fields x1 through xn and initialization expressions e1 through en, then go type check all of those initialization expressions. You'll get a tau1 through tau n. The result type for the record is a record type that has the same x1 paired with the same tau1 all the way through with the xn paired with the tau n. So the fact that we are lining up these indices matching up these names means we get a record type at the end, which has those names, the same names, with the types that we get from type checking the sub-expressions. A get form needs a record as its argument here, its argument, first argument expression. So when we type check that E, it had better give us a record type. And it had better give us a record type where one of the x1s through xn's is the name that we wrote here. So when we write xi, we mean something in that set of field names that are in the record type. And then by using tau I here, we mean get the type that matches up with the corresponding xi in the type that we got from E. And set is very similar. The only difference is we have a second expression, E2. That needs to have a tau I that's consistent with the field that we're setting, whatever xi is. And then the result type is that same record type that we got from type checking E1.